Okay, so we're practicing graphing sine with transformations. So there's no phase shift, okay? So again, the first thing I always tell my students is to graph the parent function, okay? Now I'm also going to write here the parent function with the transformations instead of numbers, okay? So we're graphing sine. So start with the parent function of sine. The parent function coordinates, these 5 key points, come from the unit circle. They're literally the y coordinates from the unit circle at those angle measures. Okay? Alright, so before we get started with our transformations, let's look at what we got. Now, this k, this -1, k is our vertical shift and represents our center line. Okay? So our center line is at -1, which means our sine has been shifted down 1. Okay? This 1/2, that's my A transformation. That is my amplitude. My amplitude is now 1/2, which means I have had my sine wave vertically compressed. The original amplitude from parent function is 1, so now it's 1/2, so it has been vertically compressed. Alright, so let's look at my period. Well, I don't have a B here, so my period is still 2 pi, so the length of my curve, no horizontal stretch or compression. And then my last one, that is my horizontal shift. Since it's negative, it's going to the right, so we're going to move it right pi. Okay? So I always tell my students start with any kind of stretch or compressions first. So we're going to start with that change in amplitude. So my first transformation is this one, changing in amplitude. So it's basically the zeros stay the same, but my maximum minimums are cut to 1/2 because amplitude is the distance from the original center line to the maximums and the center line to the minimums. And in our parent function, the center line is right here at 0. So, or you could think of it as a vertical stretch where you multiply all your y values by 1/2. Okay, so either way you want to think about it, we could do it either way. Alright, so next transformation. At this point we've got our, we don't have to change the period, so we can move it either the down 1 or to the right pi. So I'm going to move it down 1 first. So that means my new center line, like we said, this is my center line at -1. Okay? So my new center line is there at -1. And we're going to move everything down 1. So this one moves down 1, this moves down 1, this one moves down 1, that one moves down 1, and that one moves down 1. Notice that when I shifted my function down, notice those zeros that were on the y-axis, or sorry, the x-axis, are still on my center line, my new center line. Okay? And then my last transformation is going to the right pi. So this is going to be shifted to pi, this at a pi, so it's going to be here at 3 pi over 2, and then pi gets shifted over to 2 pi, and 3 pi over 2 gets shifted to 5 pi over 2, and 2 pi gets shifted over to 3 pi. And that is our transform function. Okay, and like I said, if you double check, for instance, if I say, okay, let's check 3 pi. So if I say, what is f of 3 pi, and we plug that in, so we get -1 plus 1/2 sine of 3 pi minus pi. So if you have 3 pi minus a pi, that means sine at 2 pi. Sine at 2 pi, this is 0. So 0 times 1/2 is 0, and then 0 plus -1 is -1. So are we at 3 pi -1? Yes. So most likely we've done our transformations correctly.